This is RadiCal, a remotely actuated radiation calibration system. The goal of RadiCal is to calibrate camera counters without the need for any manual involvement of the personnel.
Here is our windmill system. The purpose of the windmill is to both hold sources and to allow for better calibration for the simulation of dosage rates. The windmill is this 3D printed piece right here that holds 4 sources of both disc and capsule shapes inside of it. It's attached to this stepper motor that can reliably rotate up to 200 RPM, and this allows for much more robust calibration and also the simulation of dosage rates for better research purposes.
This is our custom-made PCB used for the control of all electronic components within the chamber. Included on the PCB are a motor driver and a door driver to run our motor and door. Additionally, we have a ESP32 used for Bluetooth communication with the app. Finally, we have a 12-volt battery that powers all systems within the chamber.
Moving on to the chamber itself, it is comprised of 2 layers. The outer layer here is made of steel panels, while the inner layer is composed of lead. The steel panels mainly provide structural support to the overall chamber, while the lead layer does the radiation attenuation. You will see that the lead panels are joined in an interesting way. Instead of having simple butt joints that you can see on the steel plates, we went for a double rabbet joint on the lead layer. This was done to prevent any straight line seams on this layer, which can cause potential radiation leakages. Together with this thickness of lead layer and steel layers, our chamber is capable of achieving 1 TVL of radiation attenuation, which means that it blocks 90% of all incoming radiation and only lets 1/10 of it to pass through, hence the name TVL or 10th value layer. This is our door assembly. It consists of 2 linear actuators, a tungsten block, and a 3D printed piece that connects the block to the actuators. The actuators can extend upwards in this fashion, which also lifts the block up and lets it cover the chamber aperture. The chamber also has some external features to help in its portability. It consists of these 2 side handles, which allow it to be carried easily, and also a top handle to allow for easy removal of the lid. The chamber also has rubber feet at the very bottom to prevent any slipping and easier use in general.
Here is our app controller that we use to control the RadiCal chamber itself. To use the app, you first go to the second page, which is labeled Devices, and you click Scan for Devices. Once the device that says ESP32 radiation chamber is available, you simply press Connect on here, and it will connect to the ESP32 on the PCB. After that's connected, you can go to the control station, to the control tab, and here's a few of the features that our app actually has. Firstly, you can control the aperture window with this button here, which opens and closes the actuator. Secondly, you can control the motor that's attached to the windmill. You could either control RPM, and you can also control how long the windmill actually rotates. And finally, you can also select a specific source that you want to go to. This is done using a Hall effect sensor that's attached to the motor stand. And as an ease of convenience, there's also a history section where you could go through all the commands you just sent to the ESP32.
I'm now going to demonstrate the app in action. It has already been linked to the ESP32 in our PCB. I'm first gonna open and close the aperture by using the actuators. This press of the button will close the aperture by moving the actuators upwards. Now I can press it again to lower the actuators and expose the aperture. I can also control the stepper motor, which is connected to our windmill source housing. I can specify the RPM I want the motor to spin at, as well as the duration in seconds. For now, I'll go for an RPM of 50 for 10 seconds. We can also use the app to control which of the 4 sources is facing the aperture opening. Right now, it is source 1 that is visible, but I can also change it to source 2, 3, or 4 by pressing the appropriate buttons on the app. Pressing source 2 makes the motor spins to the second source. Similarly, I can do the same for source 3 and source 4, and back to source 1 as well.